Sometimes I wake up and decide to tackle a project that doesn't really accomplish anything or create anything groundbreaking. Sometimes it's just nice to fool around and do things just for the hell of it. But even with that said, what even would be the point of learning how to code on a 40-year-old computer? I say writing modern software is easy, but writing software that adheres to a strict older standard will harden you. If you can code in an ancient version of C, you'll get a better understanding of the C language that will carry over to any modern version of the language. At least in theory. In practice... No! I've been playing with old Macs for years, but I haven't actually had the chance to do anything with them. Sure, it's fun to explore old programs or write an essay in an ancient version of MacWrite, but after I flip off the power switch, I'm not left feeling very accomplished. So I want to see if I can write my own game that'll run on the Macintosh. Specifically, I want to try to port Conway's Game of Life onto the Macintosh for two reasons. One, the game's logic is relatively simple. It's mostly graphics work that we're going to have to do. And two, the way that the game works fascinates me. So, first, to understand all this, we need to understand what actually is the Game of Life. In 1970, British mathematician John Horton Conway created a game known as the Game of Life, a Turing-complete cellular automaton. That sounds complicated, so in layman's terms, a cellular automaton is a system of cells that follows a set of rules, and it being Turing-complete means that it can theoretically do anything a computer could do, given enough time and space. As a result of this, I've seen people building digital clocks, computers, and all sorts of other circuits like that, although we're not going to have anywhere near enough processing power or memory to do that on a Macintosh. The rules of the Game of Life are very simple. A grid of cells are either alive or dead. A cell checks how many alive neighbors it has in the surrounding 8 cells. If a living cell has 2 or 3 alive neighbors, it stays alive for the next generation, otherwise it dies. If a dead cell has 3 alive neighbors, that cell becomes alive. If not, it remains dead. When Conway first showed off his Game of Life in the Scientific American magazine, it was suggested that the game be played with a large Go board with its black and white stones, or a checkerboard. But obviously playing it by hand is incredibly tedious and very prone to errors, so naturally nerds got to work writing versions of it for computers. The first documented version being written in Algo 68C for the PDP-7 by 2 guys named Guy and Bourne. Anyways, fast forward 55 years later, and versions of Game of Life are now available on just about any platform in about every language under the sun. And, as expected, there are tons of versions of the Game of Life written in the C language, which also appeared in the early 70s. So, how do you get that C code running on the Macintosh? Well, first we need to understand why I can't just take some code off GitHub and shove it into the Macintosh. The year is 1984, Van Halen's eponymously titled album is reaching number 2 on the Billboard 200, Ronald Reagan is re-elected, and a company named Apple Computer releases their Macintosh, changing the way that we see computers forever. Naturally, people needed to get to work writing programs for the Macintosh, and at first developers used either Apple's Object Pascal or would straight up just write assembly for the Motorola 68000 processor. In the same year, Hippopotamus Software released their Hippo C Workshop, becoming the first ever C compiler for the Macintosh. This software was great, however it was meant more for beginners, and therefore it lacked the ability to make real applications. Fast forward 2 years to 1986, the same year the Macintosh Plus came out, and Think Technologies releases Lightspeed C, later known as ThinkC, a C programming environment for the Macintosh, targeted to professional developers and named after its fast compiling times. Now, here's where the trouble begins. The C language was put together by Dennis Ritchie and Ken Thompson in 1972, 2 whole years after Conway's Game of Life itself was created. And since then, C has undergone many revisions. The trouble is, the first official revision of C, known as ANSI-C or C89, didn't come out until, you guessed it, 1989. And while there were drafts of an official C structure as far back as 1985, nothing had been made official yet. So, it was kind of up to the developers of the programming environments to choose how their C was handled. Most software from this era, including our beloved Lightspeed C, uses a pseudo-standard called KNR-C, also known as C78. This comes from a book that describes the C programming language, aptly titled The C Programming Language. Written by Brian Kerningham and Dennis Ritchie, the name KNR comes from the last initials of the author. Side note, KNR later released a second edition of this book under the same title, but that version covers the later ANSI-C, so do keep that in mind if you do try to get your hands on a copy. Anyways, with that in mind, let's see what happens if we run the first Hello World program I see off Google. I grabbed a copy of ThinkC3, then chucked it into my Macintosh, and then I hastily typed in this Hello World program and hit compile, and it doesn't work. For starters, ThinkC is not like a modern developer environment. You can't just barf up code, hit compile, and have it run. You need to give the compiler some basic information first before it can start. One thing that's always necessary when working on a ThinkC program is this library called MacTraps. MacTraps acts as a sort of middleman between the Macintosh system software and the C code you write. It translates commands, I guess. It's necessary for any project, so we'll have to add it from the source menu. Any other libraries need to be imported manually. We need the stdio, or standard input-output library, so it needs to be added using the source menu as well. Right, we've got the MacTraps interpreter, we've got our IO library. Let's compile. What? Same error. Okay, I guess it's time for some good old RTFM. Okay, so for whatever reason, not only is creating a new C file and saving it not enough, but to add it to the project, you're going to have to go to the source menu and add it as well. Anyways, now everything is in place and we can compile. What? Huh, that's weird. My code's correct. I guess it just doesn't like this version. It's almost like I spent 5 minutes foreshadowing this earlier. You see, here's where that important distinction between old C versions come in. This program works fine on a modern computer, but when I put it in here, it doesn't work. And that's because there's some stuff in our code that hasn't yet been defined in this older version of C, so it throws an error. Mainly there's two things in here, but I will point this out throughout the project as we go. For one, our main function declaration is int main void. In a modern C compiler, this is interpreted as this function takes no parameters. However, old-style compilers don't understand what the void does in this context, so it just throws an error. Therefore, we must change our main function declaration to just int main. The second thing is the way that we do comments, and this will be important everywhere in our program. C has always supported commenting by using / to open comments and */ to close. This approach allows for multi-line commenting, which is great. However, it can be somewhat tedious to have to write both an open and a closed denotation for comments. So, in modern versions of C, you can use 2 slashes to begin a comment and it will continue until the end of the line. However, KNRC doesn't support this way of commenting, so we're forced to use the old multi-line style. And with that sorted, our code now compiles and runs. Oh, well, that wasn't too bad. Well, we made a program. Now, of course, the road from Hello World to a working version of Conway's Game of Life with GUI support and all that stuff is a very long one, so I'm going to end this video here. But don't worry, there's going to be a lot more videos like these coming out soon. I decided I'd make this a series to where I try to get this done, and if I space it out like this, then that gives you guys more opportunities to chime in and give me your comments and some tips to maybe help this be a little easier for me. In the next episode, we're going to try to make a bare-bones text version first so that we can get the game logic down and have a working version of Conway's Game of Life. Then we're going to implement a GUI so that people can point and click on it and it looks like a game. Then we're going to do some optimizations to make it not be super laggy. Then some UI design touches and packaging and distribution. The goal of this project is to have a working version ready to go at VCF Southwest in June 2025 of this year. That way, if you happen to be at VCF, you can come say hi, I'd love to meet you, and you can buy a copy of this on diskette. Now, of course, I say buy, it's only really to reimburse the cost of the disc itself. If you want to play this game for free, I will have all the source code and pre-built disc images available on GitHub as I complete this project. So you can run it in an emulator, you can put it on a floppy, email it on a real Macintosh, but it's all yours to mess with. Well, anyways, if you like what you saw, you should consider subscribing. I do dumb stuff like this all the time on this channel, and I'd love to have you. We just reached 300 subscribers, which is pretty cool, I admit. Anyways, I'll catch you guys whenever I see you guys next. Bye for now.